Hi guys, in this video we're looking at points of intersection between two graphs. In this particular context it is the parabola with a straight line graph. So with these two equations, you will see that we've got a inverted parabola, and that goes through the y-axis at -48. We also have a straight line graph, which is a positive gradient, and it goes through the y-axis at -54. Through this graph alone, we can't really, unless we zoom in, we can't really see where they actually intersect. And so we can actually work that out through, solving the equations using both the discriminant and the quadratic formula. So that's what I would like to go through with you guys today. So let's have a look at these two. And the first thing is that we want to equate the two together, okay, and actually combine them. So we'll have minus x squared plus 14x minus 48 is equal to 13x minus 54. Moving both of these across to the left-hand side and combining like terms, so we're going to subtract minus 13x, we're going to add 54, okay. We'll end up having minus x squared plus x and then plus 6 equals 0. What we have is just a normal quadratic equation. And remember, our discriminant is b squared minus 4ac. And if it's positive, we have two solutions. If it's negative, we have no solutions. If it equals 0, we have one solution. Okay, so just some recaps there. So if we had our quadratic formula, so we have b squared minus 4ac over 2a, we'll know that our discriminant is 25. So this, remember, a is minus 1, b is 1, and c is 6, okay? So we're substituting these values into this quadratic formula. B squared minus 4ac goes down to 25, plus or minus negative b is going to be negative 1 over 2a, which is negative 2. Okay, if we were to simplify all of this, obviously the square root of 25 is just 5. Okay, and then we end up having our x values to be minus 2 and 3. So minus 1 minus 5 divided by minus 2 is 3. Minus 1 plus 5 divided by minus 2 is negative 2. Okay, so what we end up having, these two solutions, because our discriminant is positive, that kind of affirms everything, we have found the two x values for the coordinates of intersection, the points of intersection. So there's one point of intersection that has the x coordinate of minus 2, and we have a second point of intersection between these two graphs where the x value is 3. To work out the y values, we simply substitute each of these x values into one of these two equations. I'm going to use this one here because it's a lot easier. So we have y equals 13 times minus 2 minus 54. And the value of that is going to be minus 80. So what we can conclude is that our first point of intersection is minus 2 minus 80. Okay, our second point of intersection will have y is equal to 13 times 3 minus 54, and now y value is going to be minus 15. So that means our second point of intersection is going to be 3 minus 15. Okay, so we can go back to our graph, and you can use your graphics calculator for this to actually prove this matter here. So we can see that we've got one point of intersection there, and we have another point of intersection there. So our first point of intersection, we said it was going to be minus 2 and minus 80. So we have a look at this. we could see that this is, oops, we could see that we have -2 above here, and the point of intersection meets -80 as well. If we look at the other point of intersection, we could see that it does match 3 and 15. Okay, oh, 3 and -15, sorry. So that's the beauty of having the graphics calculator, where you could visually confirm what you have solved manually is right. And if it doesn't, then obviously you can go back onto your working out and to see where you went wrong. Could be one of those polarities. You've actually added something instead of subtracting, or subtracting instead of adding. Those things are really important that you make sure that you don't make those mistakes because they can be quite consequential. Okay, guys, hope that helps you. If you have any questions, let me know. I'll see you in the next video.